So now let's send it and see. Exactly. So now you see we have connection to the server now. Now we can do anything we want on this server. We can check the directory where we are and we send the directory where we are in. Which user is currently being run? Go to who am I? It shows the current user. And it's me. Every developer who built a profile page has built this feature. Let the user upload an image. It sounds harmless, right? A little avatar, a banner photo. But that one common innocent upload is one of the most common entry points an attacker uses on the web. Hi everyone, welcome to the channel. And if you are new here, this is where we break down web application security the hands-on way. Not just theory, not just slides. We get into the lab, we run the actual attack, and we talk about how to shut them down. If that's your thing, do me a favor and subscribe, because we got a whole series on web app exploitation, and this one is my favorite. So today's topic, the image upload exploit. Here is the thing that makes this so dangerous. It feels safe. The form says upload an image. There's probably a little check that looks at the file extension. Maybe it even peeks at the content type, and developers ship it thinking they've locked it down. But underneath a lot of this upload feature are trusting things they don't have to trust. And when an attacker can sneak a file past that gate, a file a server will actually execute, that avatar uploader stops being a profile feature and becomes a way onto your server. We are going to walk through how the bypass actually works step by step in the lab environment where I've set up exactly for this. You see the upload gate, you see how we get around it, and most importantly, you understand why it works. So you can spot the same mistake in your own code. Quick but serious note, before we dive in, everything I show you is in the deliberately vulnerable lab that I own and control, and I'm authorized to test it. This is for learning how to defend your application. Don't point this technique to systems you do not own or have explicit permission to test. This is not a gray area, it's illegal. We do this to build better, safer software. All right, enough talking. Let me share my screen and let's get into the lab. So this is a vulnerable lab that we will be looking at. First, we're going to look at the happy place. I'm going to upload exactly the file that this application expects. And then we see how it works. And then from there, you try to manipulate the content type and then upload it and then see how we can attack it. And then the next exploit that we will look at is also the content exploit, how we can exploit the content and then upload a malicious file onto the server and then execute it from there. So this vulnerable site performs some basic checks. So let me go ahead and upload a real file that it expects. So this is a correct PNG file. Let me upload this. So it accepts and opens the image. Now, let me try to upload a PHP file, and then let's see if it's going to accept the file. Great, the file got rejected because it's not an image, it's a PHP file. So obviously it's rejected it because that is what it's checking. But let's see how we can bypass the content type check. Let me turn on my Burp Suite. Let me turn on the proxy. And then now let's try to upload the same PHP file again. Okay, so now we intercept the file upload. Let me send it to the repeater. Then we can manipulate it from there. So if you look under the hood, this is what the attacker is trying to send onto the server. The content type, which is this, is PHP file. And from the application, what is checking is this content type. It's checking to find out if it's an image. And because this is not an image, but a PHP file, it's rejected. So let's try to send this and then see whether it's rejected also over here. And again, the file got rejected over here too. The file got rejected. But let's do this. Let's proof the content type. Let's change this to image PNG. And then let's send it. And there we go. Upload was okay. So at this point, our shell.php has been uploaded onto the server. And the attacker can now execute this file and issue commands. Let's go ahead and execute this file and then see how we can get hold of the server. And then before I do that, I also want to point out this to you. When you check the source code, it gives you the path where the file is uploaded. So the file is uploaded in the uploads folder. So that is where we're going to execute the shell.php file. Let me copy this. Open a new tab. Paste this in here. Go to uploads, and then shell.php. Okay. Before I go on, I want to show you the content of the shell.php file that we just uploaded. So this is the content of the shell.php. It's just a simple two-liner PHP code. So the first line, which is the echo shell, is okay. If we run this, if we execute this file, we're going to see shell okay return to us on the page, which means that we are able to access our shell file. So the second line of code also tells us if the parameter C is supplied, we should get its content and then pass it to the system command, and the PHP should execute that system command. So there's all that the file is doing. So now let's go ahead and then execute the file and see what it says. So I'm supplying, let me do PWD. So exactly, so it says shell okay, and it shows currently where I am. My current location where the file is in real sense, an attacker or nobody besides you, the developer, should be able to traverse your application files and then know the directory structure of your application. So once we get okay and we get exactly what we want, it tells us that we can perform a reverse shell on this server. And how do we do that? So to run a reverse shell, we go to the reverse shell generator over here. And then we give it the IP of our machine. So the IP of my lab here is 10.0.20.5.50.20. And I'm going to listen on port 1001. So I'm going to run this on my terminal. So what this code is doing is, this code is just sitting there listening, waiting for a connection from the web server. And once the connection is established, now the attacker will now go ahead and then execute command line codes that will do exploits on the server itself. So let's go test that out. Now I'm going to run this again. Let me show this side by side. Then you appreciate what I'm talking about. So keep an eye on this terminal. Once I execute this code, this terminal is going to establish connection with this terminal. So while our listener is set and waiting for a connection to be established, let's go ahead and then prepare the payload that we will run in the URL to establish the connection. So this is what we're going to run. Let me just copy this. And then let me form the URL over here. Then we just copy it and paste it in there. So this is the command that we're going to run in the browser to establish the connection to our terminal. So let me explain what is happening over here. So this target IP, this is the target IP. This is the IP where the application is running. And then this is the port where the application is running. And this is the directory where our shell.php is located. And then this is the command that we are going to run. It's a bash command that we're going to run to establish connection with the server. But currently, we cannot run this because this is not a format that the URL accepts. So we have to URL encode all this before we put it in the URL bar or the address bar. So this is the encrypted, this is the URL encoded form of the bash scripts that I pasted earlier. So we're going to copy this whole thing. And I paste it there. And then, so just keep an eye on this terminal. Once I execute this, it's going to establish a connection over here. So now let's send it and see. Exactly. So now you see we have connection to the server now. Now we can do anything we want on this server. We can check the directory where we are and return the directory where we are in. Which user is currently being run? Go to who am I? It shows the current user. And it's me. So with this access, there are a whole lot of exploits that the attacker can do from here. The attacker has gained total control of your server. All that he needs to do now is to have an elevated privileges, and then can run more scripts, can dump scripts, can copy things from your machine onto his machine, can access secret files such as SSH keys and passwords, all because you didn't secure your application very well. So let me exit from this. Connection, and then we try the second exploit, and then from there, we see how we can prevent some of these attacks. All right. So now we've seen how we can spoof the content type and then bypass the content type validation and then upload a malicious code. So the next thing that we now going to look at is how we can now manipulate the actual content. Sometimes web developers, yes, will validate the content type very well. Content type very well. But then the content of the file itself, they do not validate it. So the attacker obfuscates the malicious code in the content and then uploads it as an actual image. And then he goes ahead and executes it on the server and causes harm on your server. So let's look at how that is also carried out. But before I even go ahead and then do that, let me show you how you can prepare the malicious file. So let's go ahead and then prepare a malicious file to upload. So we're going to, with this exploit, you make a copy of an actual correct image that will upload successfully on the server. So for example, this is a PNG image. We're going to embed PHP code inside this image and then we upload it. So to do that, we're going to supply the terminal with this code. So we're picking the real image.png and then we're creating another image from that. Let me call that evil.png. And then inside evil.png, we're going to embed this PHP code. Then again, we save it as evil.png. So let's go back and let me explain what exactly it's doing again. So we're picking an actual PNG image, make a copy of it, and then name it evil.png. So then inside evil.png, we inject this PHP code to test whether the server is susceptible to reverse shell. So you inject this image and then we now save it again as evil.png. So let's do that. Now go into the directory and see evil PNG over there. Then the next thing that you're supposed to do to this is now we have to find a way to make this file executable because it contains PHP codes that is executable. But if we leave the extension as PNG, PNG is not an executable file, so cannot be executed. So what we're going to do is to rename this again as .php. .php. So evil.png.php is our exploit file. So this is what we're going to upload to test whether the site is reverse shell vulnerable. Let me see whether the intercept is on. Okay, yeah, it's on. So let's go ahead and send an intercept. Forward it to the repeater, then turn off the intercept. Okay. So under the hood, this is the image that is going to be sent to the server. And if you look at it, the server again identifies the content type as the file content type is a PHP file. So, like as we tested earlier on, if we upload this file like this, it's going to get rejected. So we change the content type to image/png. And then when you scroll down, I want to show you where the PHP script was injected. So you see here, this is our PHP file. So if we manage to get this file onto the server, this is another way we can test whether the server is susceptible to reverse shell attack. So let me send this, then see whether we get a successful message. Let's go down. And again, okay, uploaded, okay. We've successfully uploaded this file. So ladies and gentlemen, moment of truth. This is where we're now going to test if we can run this file and then gain access to the environment. evil.png.php. No, first let's just run it without passing the parameter. All right, so we've been able to load this page. So now that we've been able to upload the file, let's test to see if we can have reverse shell access. So to do that, I'm going to paste the code we're going to use over there here. So we're going to change the IP that we're listening on to our IP address, that is 10.0.50.20. And then the port right here is 9001. And everything has been URL encoded. So let's go ahead and copy it. Then before we paste it in there, let's start our listener. So the listener is on. Let's go ahead and test to see if we can have reverse shell access. So bear in mind, we run it from the evil.png.php file that we uploaded. So let's see. Just keep an eye on the terminal here. Have our remote shell access. There we go. So now we have our remote shell access. And again, we can do whatever we want from here. Check ID. We check who am I. And we can go ahead and then execute more commands that we can go ahead and execute any command that we want, but this is not an exploit tutorial. So I'm just going to leave it here. This is just to prove, this is just a proof of concept that the server is susceptible to reverse shell, which we've successfully been able to do. And there it is, a working image upload exploit from a harmless looking form all the way to code running on the server. You saw how the upload got bypassed. Now, I know what some of you are thinking. This is very scary. How can I stop it? And that's exactly where we're going. But this is the natural stopping point because remediation deserves its own focused walkthrough. In part 2, which is the remediation part, we'll roll our sleeves and then fix it. We will look at server-side validation, checking the real content, re-encoding image, safe storage, the whole defense in the stack. That's the video that turns you from someone who understands the attack to someone who actually shuts it down. So if you want to see the fix, part 2 is either on the channel or dropping right behind this. Hit subscribe so it lands in your feed. And if this one helped you, just drop a like. Before I close part 1, I would like to take a moment and say a prayer for everyone that is watching. Father, thank you for everyone who took the time to learn something today. Thank you for your minds that want to understand how things work and hearts that want to protect what's been placed in their care. Guide the way they use what they've learned with honesty, with integrity, always to defend and never to harm. Give them wisdom in their work and peace when they step away from it. Watch over them and the people they love. In your name I pray. Amen. Thanks for watching part 1. Go catch the fix in part 2. See you there.